Hi guys, happy Monday. I hope you had a wonderful weekend. I miss you, but I'm excited to see you tomorrow. I'm glad you found your way back to my videos. I'm going to be demonstrating a new rule today called the chain rule. We're on lesson 3 of unit 3. You can find yourself at this appropriate page in your packets, and just like last class, I'll show you these notes and then give you a few practice problems to give you some support on your upcoming assignment. The chain rule for derivatives is something that is going to be one of the trickier rules of this unit, and it really emphasizes functions that are presented to us as compositions. So on Friday, we honed in on products and quotients that were showing up in our functions, and today it's going to be composed functions. So if we have two separate functions that are differentiable everywhere, the derivative of the composition of these functions, f of g of x, can be found using the following derivative rule. The derivative of our composition is equal to f prime of g of x times g prime of x. That form is good for some folks and not good for others. So we can also use the notation described next, that if y equals f of u, and if that's differentiable, with u equaling another function called g of x, and that's differentiable, then y equals f of u would be the same as f of g of x, also differentiable. And we could find our derivative by taking the derivative of f, keeping that u intact inside of f, and then multiplying by the derivative of u with respect to x. This is a lot of tricky notation. And in words, what we will oftentimes ground ourselves in is this saying right here. The derivative of a composite function is the derivative of the outside function evaluated at the inside function times the derivative of the inside function. It's a lot to dig into, and we're going to try our hand at our first model problem right now. So when I look at L of x, I definitely see a composition of functions. And I know this is your first pass at this, but what I want to try to do is create L of x and think of it in such a way that I'm recognizing that there's an outer function that I have subbed a new function into to get the composition that we see. What I'm leaning toward here, if I want to just explicitly define these two functions that I'm composing, I'll often do this by asking myself, all right, Blakely, when I look at L of x, what function appears to be on the inside? And hopefully you can agree with me that the function on the inside here is 3x squared minus 5x plus 2. That function is inside of the square root. So we would say that the outer function is square root of x. My pre-cal students are great at this because we spent a whole unit on this. We worked really hard to compose the function g of x into f last year in pre-cal, which means I would write the square root that belongs on the f function, but in place of the x, I'd sub in the entire g function. So here's just some algebraic support that these two functions do in fact get the composition that we started with over here. But more importantly, I want to try to apply this new rule to this composition. The new rule says that the derivative of a composite function, all right, I've got a composite function, is the derivative of the outside function evaluated at the inside function times the derivative of the inside function. So let's make sure this is really clear. Our outside function is f of x. Our inside function here is g of x. So I want to find the derivative of the outside function. Let me do some annotation here. I can do that. This is one I asked you to memorize. 1 over 2 square roots of x. And I'm going to, according to this, take the derivative of that outside function evaluated at the inside function, and then multiply by the derivative of the inside. This is kind of crazy. I've got my derivative of the outside function, but this one is evaluated at x. And that's not what this says. This says to evaluate this at the inside function, which is right here. What we're going to see here when I start to find my derivative is that I am going to anchor myself in 1 over 2 square roots, but instead of a square root of x, I need the square root of the inside function, which is called g of x. To finish this out, I'll then multiply by the derivative of that inside function. So check this out. I've got g of x. I circled it over here in blue. I can easily find g prime of x using my power rule. That's 6x minus 5. When I sub these two things in over here, what I'm actually able to get to is that the derivative of the function L is 1 over 2 square roots of 3x squared minus 5x plus 2 times 6x minus 5. Or if that bothers you, 6x minus 5 over 2 square roots of 3x squared minus 5x plus 2. There's your first derivative by way of the chain rule.